In the previous video, you learned that the annual equivalent interest rate, AER for short, could be used to compare the interest paid on accounts. We calculated the AER in this way. Interest earned by leaving an amount of money in an account for a year over the original starting amount of money. This gives the AER as a decimal, and you can change it to a percentage by multiplying it by 100. Sometimes people want to be able to find the AER quickly by looking at the interest rate being offered and the interest compounding period, monthly, quarterly, or yearly. In this example, 3 options are offered. Look at the different terms used when describing the interest. These mean different things. Now you already know about the AER, but for the quarterly interest, we have 4.90% nominal, and this means that at the end of each quarter, 4.90 over 4% interest will be paid. From this definition, can you work out the interest paid at the end of the month for the monthly account? You may wish to pause the video. So for the monthly account, the interest paid at the end of each month is 4.89 divided by 12, as there are 12 monthly compounding periods in a year. So in general, the interest paid for a particular compounding period can be found by dividing the nominal rate by the number of compounding periods in a year. But that's the interest paid for a compounding period. What if we wanted to find the AER? Let's find the AER for the quarterly account. To find the AER, we begin by finding the quarterly interest, which we have already shown as being 4.90 divided by 4, and this equals 1.225%. We can also show this using decimals. The decimal equivalent to 4.90% is 0.049. So, 0.049 divided by 4 is equal to 0.01225. And this, of course, is the same as 1.225%. Now for the following calculations, I'm going to use the decimal equivalent. I'm now going to create a multiplier for each quarter. The multiplier is 1 at the quarterly interest, which is 0.049 divided by 4, and this is equal to 1.01225. Let's use the multiplier in an example. Imagine you are investing £1,000. We are going to calculate the balance after 1 year. Now the interest is going to be added every quarter. So using the multiplier to calculate the balance at the end of the year, that will be 1,000 multiplied by the multiplier to the power of 4, the 4 representing the 4 compounding periods over the year. And this works out at 1,000 multiplied by 1.049907751. I'm going to keep this balance as a calculation. We now need to calculate the interest after 1 year. So that is the balance at the end of the year, subtract the original amount put in, which is 1,000. I'm also going to keep this as a calculation. Now let's find the AER. Remember, the AER is the interest divided by the amount invested, and this can be simplified to 1.049907751 subtract 1, and this is equal to 0.05 to 2 decimal places. As a percentage, this will equal 5%. So whatever you invest, the interest rate works out to be approximately 5%. Now if we go back to this line here, remember that this decimal is the multiplier to the power of 4, where 4 is the number of compounding periods. So we could have written the AER for the quarterly account as 1 add 0.049 over 4 all to the power of 4 subtract 1. And we can use this to create a general formula for working out the AER. So the formula for calculating the AER is R is equal to, open brackets, 1 add I over n close brackets, all to the power of n, subtract 1, where R is the AER, expressed as a decimal, I is the nominal interest rate, expressed as a decimal, and n is the number of compounding periods in a year. The value R will be given as a decimal. Use the formula to show that the AER for the monthly account is also 5% when rounded to 2 decimal places. Remember to use the decimal value for I in the formula, and that R is the decimal value of the AER.